Okay, good afternoon, everybody, and welcome back to Sunoikisis's Digital Classics Summer Term 2021. Today is our 11th session, and we have a session about citation for historical text and the Cited Loci project. Our guest today is Matteo Romanello, Research Fellow at the University of Lausanne. Matteo has been contributing a lot to the Sunoikisis program, and he has been working a lot in the last years on citations of historical text. So today he will show us the last updates of his project and his work. And today we are also very happy to have with us Sam Husky, a professor of classics at the University of Oklahoma and director of the Digital Latin Library project, which will be presented next week. So Sam Husky will be our guest next week for an entire session about the Digital Latin Library. But today we can begin with this discussion about citation for historical text, and definitely in the discussion we will also talk about catalogs of classical authors and also about the Digital Latin Library. But okay, so Matteo, welcome back to Sunoikisis today. Thank you for joining us again. And now it's okay, so it's your turn. So,
well, many thanks, Monica, for the kind words of introduction. It's a pleasure to be back in to the Sunoikisis. So I can share my slides. I not see you anymore, so just say that you can see everything fine, and I can start.
Yes, everything is fine. You can start.
Great, thanks a lot, Monica. So yeah, as Monica mentioned, so the talk of today, it's going to be about the Cited Loci pipeline, which is a citation mining pipeline to extract citations to classical authors and works contained in scholarly publications full text. Here you have an example of what they actually look like. So here you have a paragraph with, in brackets, quite a few kind of consecutive citations to different places of Homer's Odyssey. So this is the object of the talk. This is the type of canonical citations that the Cited Loci pipeline allows you to extract. How is the talk of today organized? So I will start a bit with a bigger picture of why are these kind of citations important, what are the type of citations there are in classical publications, and what could be the goal for actually doing this. What does it bring? What does it bring if we extract and enrich publications with these type of references? Then I'm going to dig a little bit into the technology without too many details, but discussing some of the components of the pipeline. Then I will go back to them in the hands-on session at the end of the talk. And then I will continue with 3 applications of the usage of this pipeline. I have been using it in my research and also in some industry collaborations. So the applications will be about information retrieval, scholarly publishing, and the study of scholarly reception. And then I will conclude a bit with an outlook on the project, how we will continue over the next years, and what are we doing right now actively on the research side. So I will start from the very beginning just to say that the articles, monographs, and commentaries, so essentially all secondary literature in classics, is extremely rich in terms of references and mentions. Not only there are references to authors and works and their passages, as we have just seen, there are also mentions of places. This can be modern or ancient. There can be mentions of other types of texts, like inscriptions, papyri, and also of other objects beyond text, like, for example, coins or museum vases. So all of this makes for some literature that is extremely rich and dense in terms of these references. And although information retrieval and NLP and computer science more in general is not actually focusing that much on classics, they are a really an extraordinary playground for any information extraction task, because there is just so much to mine, to extract from them, and also so many problems that we will see that they arise when we try to make use of it. So why is it important to index this type of citation? So my answer is they are an essential, so citations of ancient works, of classical works, they are an essential entry point for the readers to the content of the scholarly literature. If you just think about, for example, being able to find all the articles citing a given line of the Aeneid, that becomes an extremely useful way, especially for scholars dealing with texts and matters of literature and philology. They are an extremely valuable means to access their content. How we are doing it with a Cited Loci pipeline is using an NLP-driven approach where we don't actually do it manually, but this task is automatized or semi-automatized, and we will see, since there is still, in some cases, the need for manual correction. And this NLP-driven content enrichment allows stakeholders like publishers, libraries, and digital libraries to make use of this enriched content to provide new useful services to the reader. So this could be services like clicking on a citation contained in a journal article and reading the full text of the primary source, but it can also be services about the discovery of the literature. You can think of it as a sort of an index that is created automatically or semi-automatically that allows you then to point to various literature that is citing a given passage or mentioning a given object or person or place. And by doing all of this, what we actually do, because we are creating links between literature and the objects, the text they are talking about, we also create and make explicit a web of knowledge that is actually already implicitly contained in all this publication, just not yet accessible in an explicit way. And what do I mean by this? What I mean is that it's not that indexing this type of information, it's something new. I mean, classical scholars have been doing it for centuries, really. Creating, not for all type of publications, but especially for books and monographs, creating these kind of indexes that they allow you to quickly see in a given monograph, these are the pages and the passages where the Apollonius Rhodius Argonautica are cited. So they have been doing it for centuries. But I think right now we are at a turning point where we are changing the means of representing this index information, and this change of medium, of format, actually makes a huge difference. Because if you think about the difference between an index and a graph, they are two very different objects. So the index is basically a silos, so it's one for each publication, allows you to navigate within the publication, but doesn't communicate with the world, with the knowledge surrounding the publication. Whereas the graph, by definition, is connecting things. So if you think of the occurrences of references and mentions in an article, once you extract them and you link them to the object they point to, then all the other works of literature that are referring to them, they can potentially be attached to it. So the index gets transformed into a graph that allows to navigate between this information that is extracted, and also to discover the literature. So you can go for certain passage of the Metamorphoses and discover all publications and articles and books and commentaries cited. Of course, provided that this information has been somehow extracted and formalized. So this is a bit about the why, but then there is also kind of an urgency for us, especially in the field of classics, of actually caring about the citations and how we expose them, and how we expose them to make our literature findable and more easily accessible to researchers in other disciplines. And to realize this urgency of this issue, there is this blog post by Peter Jstor called The Citation Problem, which I very much recommend, where he's actually deconstructing this problem. Whereas in other disciplines, like for example, astronomy, they talk about classics-related problems, but then barely citing the literature we have. And to quote him, at some point in his blog post, he writes, "When non-classicists write about Homer, it seems they are allergic to reading any actual research on Homer, and this can be a problem." So what he did was to analyze the type of citations in paper from other fields of research that deal with classics matter. And he found out that a very low percentage of the cited publications are from classics, which seemed to indicate essentially that this literature gets ignored. And he says, I have two hypotheses as the root of the problem. Homeric research is difficult to get to grips with. There is a hell of a lot of it. Articles don't often get translated the Greek, but any field is complex and difficult for an outsider. So I don't think this can be the main reason. So it's not the complexity of the field and the matter itself. And the second hypothesis is that the existing research is actually invisible to them. It's because there is very little overlap between bibliographic databases that cover the natural sciences and bibliographic databases that cover Homer or other topics that have to do with antiquity. And then he gives an example of actually, based on Homer, if I'm not mistaken, of how difficult it is to find relevant literature using Google Scholar. And then he concludes the post saying, basically, unless Google Scholar decides to improve its algorithms, you can expect to see more scientific papers on Homer written by people who have done no research on Homer. So if we combine this argument with this discoverability and accessibility that brings the fact of extracting citations, then we can think for the future a bit, trying to have a bit more optimistic take than the one of Jstor, of a future where we actually have citation indexes similar to Google Scholar, but that they expose the information that is important for humanities scholars, like not only secondary literature, but also primary literature. And the example I show here, overlaid, of course, with Google Scholar, it's from the Venn Scholar, so another project on which I've been working in the past few years, that actually tried to create a prototype of a citation index for the humanities, taking into account these needs, for example, of indexing citation to primary literature, but in a different domain, not reading classics in the history of Venice. But what we created at the end as a prototype is a citation index where you cannot only browse the links between cited articles and monographs, but you can also see the primary literature, meaning the archival sources that are cited in there, and find out which other publications are citing them. I don't have yet something similar for classics, but if we try to kind of prospect on the longer run this work of Cited Loci, I think that would be the goal of having a citation index that actually works well for classicists because it's indexing not only secondary, but also primary literature. And if you're interested on this, there is actually there is an article that is also in the readings for today's session. And also I wanted to give you a little bit of a kind of historical perspective on the project, because it's a project on which I've been working for quite some time, as Monica mentioned at the beginning. So actually, if you look at the number of years, it's quite a long time. So it's a bit frightening. But I started working on it between 2009 2015 when I did my PhD at King's College London. So it was conceiving this pipeline was the topic of my PhD. But then the code, the implementation that there was at the end of the PhD was not really something production ready. So I spent a couple of years during the postdoc working also on other projects to consolidate what I had been doing for the PhD and develop kind of the first prototypes. And a couple of years later, came also the first both for research and also for industry collaborations, namely with publishers like De Gruyter. And right now, I'm going back to it, both to apply to my research on my current project on the analysis of the history of the commentaries to Sophocles' Ajax, but also what we are doing is to do a technological update and some further research on the extraction of the references itself, because as you can imagine, from the time when this all started, but also let's just say from when I finished my PhD, quite a few things have happened. So technology in itself has evolved, new libraries have appeared, some others have died out, programming languages have changed. For example, you have Python 2 being now totally obsolete and having everything that needs to be ported to Python 3. So quite a few changes on the technology side, but also on the research side. If you think of the revolution that has happened in NLP research due to the sort of explosion of neural technologies in the last, let's say, 5 years, there is lots to update in what I had in this Cited Loci pipeline. So now we can go a little bit into the technology, seeing a little bit how it works. So essentially, the task of extracting canonical citations is broke down into 3 steps. Here you have an example with a paragraph containing some citations, and then for each step showing you what is kind of the outcome of that step. So we start with a plain text on which we do the so-called named entity recognition. Basically, we extract the citation components. So I model canonical citations as a mix of components that you can find in the text that they're related to each other. For example, you have the component in blue, which is called referwork, which stands for reference to author and work, that captures an entity that points to the title of the work being cited. And then you also have the scope of the reference, the purple bubbles. And these are the passages of that work that get cited. So in the first step, we extract all of these components. In the second step, in the relation extraction, we look at the relations between them. Like here, with example of Primis Naturalis Historia, you have 2 consecutive references that refer to the same work. In this case, they are close to the title reference, but in some other more extreme cases, they can also be very far away apart. Meaning, we need to link them together, and this is done by means of relations that gets established. So each reference is essentially a relation between a reference to a work and the scope that gets cited. And then finally, the third step is the so-called disambiguation, which consists of assigning to each reference, so to each relation, but also to each component, a unique identifier. What kind of unique identifier we're using? We're using the CTS-CRNs, so the Canonical Text Services Unique Resource Names, which is a standard that was developed in the context of the Homer Multitext project at Harvard's Center for Language Studies by Neil Smith and Chris Blackwell, where they developed this system to assign a kind of human-readable identifier to references to authors or works or passages of them in a way that represents kind of the hierarchy of the work being cited. So for example, you have the notion of the corpus of Latin or Greek literature, then an identifier for the author, an identifier for the work. You can also have an identifier for a specific edition, and all of these packed into the same identifier. So they are very handy from this point of view. And then in the last part of the URN, you can also have the scope identifying the specific bit of text you're talking about, like in this case, 11.4.11, which is going to be book 11, chapter 4, section 11, or something along this line. So these very compact and human-readable identifiers, they can be used to disambiguate the mentions and the references we have in the text. So this is essentially what it boils down to, extracting canonical references. Yeah, I had also the breakdown of the syntax of the CTS URL that I just explained. Now we have seen how it works. This is how it's implemented. So there are different components that take care of different steps of this pipeline. So extracting the citation components, for example, is done by the citation extractor. The citation matcher takes then care of two things. Tries to match the reference of the work against a database. So in this case, tries to find the identifier corresponding to Verge created. And then the second thing that it tries to do, that it does, is to, via the citation parser, is to normalize the citation scope. So as you have here, in the example on the right, here you have three different ways of representing the same scope of a citation in three different kind of human-readable ways. So you have 12.10 F, 12.10 S, and then with a Roman numeral 12.10 S. They all mean the same thing, but they are expressed in three different ways that, of course, are not machine readable. So in order to be then able to build a CTS URN, we need to normalize this scope into a citation that spells out the element. For example, here the abbreviation F or S that stands for following or suivant, depending on the language in which is the reference. It needs to be unpacked because for the human, it's clear that following line 10, there is a line 11, but it's not clear to the machine. So this needs to get unpacked and normalized by the citation parser. And at that point, it's possible to build a CTS URN that gets attached to the reference. And the knowledge base plays a very, very important role in all of this. And I will do a little bit of kind of zoom in into this component of the pipeline, because I think it's also interesting for the discussion, and it's also a good link for the next session on the digital Latin library. So this knowledge base contains knowledge about authors, about their works, and their text passages. This knowledge is in the form of name variants in different languages and also with abbreviations. It's in the form of unique identifiers, like the CTS URNs that we have just seen, and also similar to name variants, also title variants for the works. And this knowledge base, it's essentially a database that uses ontologies and other semantic web technologies to express and publish the information contained in the database. That's why it gets called more knowledge base. And underlying this knowledge base, there are some ontologies that allows me to represent the semantics of the data. So this, in this slide here, without going into details about the ontology modeling of all of this, but you have a representation of how to make explicit the meaning of a canonical reference. So in this case, you have a canonical reference to Verges N8, book 1, line 1 to 11. If you need to formalize this and to unpack the information that is contained in there implicitly, essentially the content of this citation would be a list of text elements, a list of canonical text elements, which represent book 1, line 1 to book 1, line 11. So it's the content of the citation is this list of text elements, and these text elements are part of a text structure, so of a logical text structure of a given work, in this case of the N8. So this is how it's modeled, the information in the knowledge base. Here I have essentially some more details about the contents. So names, titles, and identifiers that I've just mentioned, and also links, not for all of them, but for a certain part, links to Wikipedia pages of ancient authors, and then a part that it's still in progress, also citable units of each canonical text, meaning essentially for the N8, there will be all the books represented in there, instantiated, and also all the lines for each book. Meaning, each of these text elements will get a CTS URN. We'd also get a resolvable URI, meaning we can refer to it in RDF when we make statements about any of these passages. And I had also some stats about the content, just to show that there are, for author names and work titles, there are some authors and works where there are only a very limited number of variant names or variant titles, and others where you have up to 27 different name variants or 31 different work titles. So it's very varied also the way in which this knowledge is distributed. And since I spoke at the beginning about producing also making this knowledge explicit, creating a knowledge graph and a web of knowledge. This is in these slides you have an example of URI that points to one specific text element. So if you recall from a few slides before, I had this diagram with the different text elements to which a canonical reference is pointing. Well, when they are instantiated, they get a resolvable URI, meaning you can look it up. If you look it up in a browser, then you will get pointed to a front end. In this case, is the Druid platform to publish RDF data, where you have like a clickable representation of the RDF. But if you resolve it not in the browser, but using command line or a library, and you ask to get some RDF, then you will get an RDF representation of the same resource. And as you can see here, there is formalized the information that the knowledge base contains about Orme's Iliad, line 1 of the first book. So you have the CTS URN that identifies it. You have the type of this element. In this case, it's a line. You have the notion of this text element belongs to book 1. And also you have the chain of text elements. So we know that 1.1 precedes 1.2. And then you can also resolve it to via the CTS protocol to actually get the text of it. And then you have a human readable label to represent it. Maybe if it's interesting, we can also come back to this later. So that's it for the technology, what I wanted to say. A few words about the current limitations of the pipeline. So the accuracy of the extraction and the linking still offers margins for improvement. So it's still not perfect. You will see also in the hands-on part, there are references that are skipped, that are not properly extracted. Another limitation is that I focused only on canonical references, but this is not the full spectrum of references, as I mentioned at the very beginning, that you have in there. You have references to inscriptions, papyri, coins, potentially many other type of objects that get cited, and we are not capturing them right now with cited Loci. The current implementation is also became not anymore up to date with the state-of-the-art ENLP, mostly because of the rise of neural models and neural methods, meaning there would be the need to updated from that point of view. That's something we are working on currently. And if you're interested to have more details about the actual technology and also evaluation and other details, I have put here the link to a preprint where you find actually quite a bit more technical information on the pipeline. And now we can move to the three applications that I wanted to present. With the first application of the pipeline being Jstor. So what I did was to essentially take all the classics articles that are contained in Jstor, and via a license agreement with them, I got the dump, and then I was able to run all this content through the Cited Loci pipeline. So something that I should say up front is that, as you probably know, Jstor is not open access. So we're talking about paywall materials that nevertheless gets made available for research purposes to researchers. So it's a bit of a trade-off between working with not open content, but having, on the other end, a unique access point to get all the literature, a lot of literature in a certain subject. So we have it with Jstor, mostly for English secondary literature, but not for all languages. We are so lucky to have this type of platform where you can actually get access from a single point to a lot of the literature. So from the mining perspective, it was very convenient to work with Jstor, knowing that there are some limitations concerning the license, and also knowing that if you compare the distribution of languages in the Jstor content with the reality of philology, you realize that there is a strong bias in Jstor naturally for Anglophone content. Having a 75%, almost 75% of the articles in there that are in English. Of course, this doesn't match the reality of classical philology, where there is actually the publication are more spread also with other languages that are very important for classical philology, like German, French, and Italian. So there is a certain bias that one should be aware of, especially when using this data to make some conclusions about, or some research about receptions, that we are looking especially at reception in English-speaking literature. So what I did was to take all this content, run it through the pipeline that I walked you through a few slides before. I also did some evaluation of the accuracy of this process of extraction. As you can see, without going, again, not too much into the details, we are not at 100%. So there are some tasks like the relation detection that is relatively easier with a very high accuracy rate measured by the F-score, but the name identity extraction or the disambiguation, still they are below even 80%, showing that we're not talking about sort of perfect extraction of these references. And then I thought, how can I show the usefulness of having extracted all these citations from Jstor for the actual classical scholar? So what I did was to develop this small prototype, which is called Cited Loci N8, which is essentially an interface taking only the N8 as a use case, but showing how this citation data can be used to bring a rich information retrieval experience to the user. So it's a browsable interface. You can try it out yourself online, where makes accessible over 5,000 articles, from which there were extracted lots of references and also quotations. So not only the reference, the citation of the passage, but also kind of the verbatim, the word-by-word quotation of the annotate, if there was any. And this was in collaboration with the Jstor lab, so they did the part on the text reuse, on the quotation detection, and I combined it with my part on the references. And what we developed, to give an idea of what would it be to browse the information in this way, is to have this interface that essentially combines different levels of reading. You have a form of distant reading on the left, and two forms of close reading of different types of literature. So you have the focus on the text of the annotate in the middle. You have a map of quotations and references on the left side that you can use to navigate. And then based on which portion of the text you select, then you get a close reading panel of the literature, essentially. So for example, here in this slide, I was reading a certain number of lines of book 6, starting from this heat map to select the section of the text. And then the interface is showing you on the right articles from Jstor where this section of the annotate it's either cited or quoted. And this information was extracted automatically again. At that point, you can go to Jstor, and if you have access to it, continue the reading. So it could be a quite useful way of accessing the literature, especially if you are interested in a very clear set of passages of a given text. I should have also said that the heat map shows you the density of references and quotations. So you can look at both of them all together. You can also look at either of them separately. And the density, it's per chunk of text. So I chunked each book of the annotate into chunks of 50 lines. And then per each chunk, it's computed this density. And this leads you to the color, where the darker is the cell, means the higher density of references and quotations. If we move to the second application of the cited Loci pipeline, this is in the field of scholarly publishing, and this was the collaboration I mentioned at the beginning, together with the Kreuter. So the pipeline was actually used this time in production, not to index Jstor to create some interface, but actually to create an index locorum. So an index locorum of a real publication that got eventually printed. And it's a huge publication. So it's a publication in 4 volumes with 60 contributed authors, more than 60 chapters, and almost 3,000 pages. And as you can imagine, also lots of references. So it was edited by Christiane Reitz and Simone Finkmann from the University of Rostock, and it was part of the Epische Bauformen project, where they looked at types of structures in epic poetry, from Homer to Neo-Latin authors, so covering a really wide spectrum of literature. So in this collaboration, we applied the pipeline to produce the index that then got included in the final PDF that got printed. So it was really an experiment to see, since it was going to take a very long time to index all the citations that it contains manually, we tried this semi-automatic workflow where the cited Loci pipeline is used to extract the references, and then they are corrected in order to make sure that the index is as correct as humanly possible. Here you have an example of a passage very rich in terms of references. Overall, there were some 20,000 references in there, with an average of 300 per chapter. But then the distribution was also very skewed. I mean, some chapters with only 3, and a maximum of 1,000 references per chapter. So really, lots of them. It was actually the only index of the publication that we did semi-automatically. The other ones were more feasible to do them manually, and they were done manually. So the only one that was done semi-automatically was the index locorum. And overall, just to give you an idea of the extent of the index locorum spread across the 4 volumes is long, is 87 pages long. So quite a lot of references in there. And the process was to take some chapters. So the first 4 chapters that were ready, these were used as additional training data to train the pipeline, essentially. And then there was a team of graduate and postgraduate students that went essentially on the references and verified them manually. And this work of onboarding the students, explaining them the correction task, and also having them to work was one of the things where I had to find a solution that was kind of easy to explain, easy to work with, and that will integrate well with a pipeline. And I've been using, with a very good experience, the Inception annotation platform, which I believe has been mentioned also in some earlier Sunoikis episodes, so to say. And this annotation platform has now been integrated with the Cited Loci pipeline, and also with the underlying knowledge base, meaning students were able to select identifiers from the knowledge base directly from Inception, because Inception has an interface to SPARQL endpoints. And since the knowledge base has a SPARQL endpoint, it was possible to plug it into the annotation platform to enable this automatic, this manual correction. And there was also kind of a byproduct of the printed index. There was an interface that you can access freely online at the link here on the slide. And this interface was a bit of an experiment with the trying to find a way in a digital interface to represent the same information that you have in the indexes of the printed volumes, but in a more dynamic way. And what we ended up with is essentially 4 columns that represent the indexes that you have also in the printed publication. But these indexes, they work as dynamic filters. So you are able to mix them together. So you can formulate queries that are also quite sophisticated. So you can, for example, ask, given from this publication, all the paragraphs that mention the keyword council scene, which is a type of scene in epic poetry. And they also cite a certain book of the Argonautica and also Virgil. And this, naturally, it's a very interesting way of combining together the same information that you have in printed indexes, but in a digital interface that allows you more interactivity, the possibility to export your results. And then, of course, we are back to the problem of licenses. Here we display an excerpt of the publication, but you will need access to read the full text. But at least you should be able to gauge whether this publication is relevant for your research before getting access to it, for example. Doing this in practice, it was quite complicated in the sense that we had to bring the Cited Loci pipeline into the editorial workflow, which is made of deadlines on the side of the publisher, the work of the authors, the fact that in order to start with illustration, you need to wait for the final version of the manuscript, because otherwise the the corrections done by the students, they are done on a version that is not final. And then you also deal with multiple formats, because the typesetting itself was done in LaTeX. The writing and the editing by the authors and the editors was done in Word. The citation indexing pipeline was working with the plain text, and then PDF was the final format for the printing, and then again another format for the digital companion. So having all these formats working together was not that easy, with quite some problems of realigning of different formats of the same manuscript, branching at some point, and then the problem of realigning it. And typically, one reason to realign it is that in the final printed index log column, you need to indicate the page where the citation occurs. And to know the page, you need to go in the PDF and find the actual paginated page number of the page where you have a reference. So all these references are selected from the plain text, but then at some point this plain text is realigned with the PDF in order to get the final page number. So a bit of lessons learned. The experiment was still worth given the extent of the publication and how many citations it contained. So we still believe that doing that manually, it would have taken much longer. At the same time, it takes a couple of very brave editors to embark on this kind of experiment. And also is a bit of a disproportionate investment for a single publication. But if we think of, apply this process not only to one publication, but to entire series or offers of publishers, meaning if this whole process gets more streamlined, then probably then the investment will pay off. And then I can go on the final example of application, which is from reception studies. And I hope I'm still doing okay with the time. Tell me, Monica, if not.
Yes, you still have 15 minutes. Okay.
Yeah, I will wrap it up also because I want to get to do a bit of the hands-on. But so the final application is from reception studies. So there's essentially the idea that citations, so these citations that we have seen we have been extracting from text, they are traces of scholarship. So they are the traces left by scholars in their process of engaging with the sources, in writing about them, proposing interpretations. So we can consider any of these citations as a trace of a scholar that has dealt with a given author or work. And as such, these traces, they tell us something about the history of classical scholarship itself. So analyzing from this angle, from the angle of scholarly reception, the citation data extracted from Jstor, there were a couple of things that are quite interesting that came up. Where the first thing is the fact that you have a canon of the most cited authors that is kind of emerging from the extracted citation data that we have seen already. It's not perfect, so there is still some noise in there. But despite this noise, the evidence that comes from the data, it's quite interesting and aligns well with other research. So what I found out was that basically 1% of the Greek and Latin authors accounts for 30% of all references in Jstor. And here, to do this type of analysis, I'm a bit abstracting away from a reference to a specific passage, and I am abstracting it to its author. So if, let's say, there is a citation to a certain passage of the Aeneid, I will count it as a citation to Virgil. That allows to then create a network on which you can do this type of counting. And the interesting thing is that this the list actually of authors in this canon that was extracted from the data, it essentially matches with the results of another paper right now a bit dated, by Sjtor, Continuity and Change in Classical Scholarship, where he did a very different method. The method was manual and not using Jstor, but using the philology. So counting essentially how many articles per philologic volume were published in a certain year regarding a certain author. He could not do it systematically for all the volumes, so he was doing it manually with a sample, every other author. But this, the list of articles of his canon doing this type of analysis essentially matches the evidence that came from the Jstor data, which is interesting. And the second interesting thing was trying to compare the citation data from Jstor with some work in the reception. So notably, there was this article, this book, sorry, by this article by Tsiolkovsky, Ovid in the 20th Century, where he's looking at the reception of Ovid and Virgil in fiction, so not in scholarly literature, and he identifies some waves. So starting from the assumption that Ovid and Virgil, they represent kind of two polarity, two very different opposing sets of values. And there is no period that can be at the same time Ovidian and Virgilian. So it's either Ovid or Virgil. And he describes these sort of waves for reception in fiction, and comparing the data, the waves he identifies with the citation data from Jstor, there is actually quite some overlap. Without going into many details, you will find it in one of the readings, but it's that was quite interesting to see how actually the picture that we get from the citation data evidence, it reflects quite well what was said by other scholars in reception. Looking a bit ahead, as I mentioned already, there is a technological update on the machine learning models for the extraction and the disambiguation, but also on the implementation of the pipeline, not the porting of the code from Python 2 to Python 3. Right now, we're also working on applying the Cited pipeline on OCR, the classical commentaries. So far, we did monographs with structures of epic poetry, articles, abstracts, and now we're adding also OCR classical commentaries, which are historical documents, and they bring new challenges in terms of notably the OCR noise and the OCR quality. And we're also looking to expand the range of captured references. So also looking at mentions of people, scholars mentioned in the commentaries, ancient and modern places, and so on. Also we will try to, we're working on publishing the annotation guidelines that can be helpful for others to do similar annotations, and also the annotated data. And also we are continuing the collaboration with scholarly publisher, this time with Brill, in a project which is led by the University of Amsterdam and involves also Brill as an industry partner, which is called Books to Knowledge Graphs, where we are essentially looking at this, how to streamline the application of this type of pipelines on the contents owned by publishers. And that was it. You can stop the screen sharing if you want. And depending on the time available, either we can go for only the discussion, or I can show a little bit the hands-on.
But you still have, so we still have time until 6:15. So,
Okay.
Matteo, if you want to show something, yes, of course.
Yeah. Then I will move to the notebook. Maybe just before the notebook, I also wanted to show the GitHub repository. So it's called Index Log 101. Basically, I realized that getting the machinery of the pipeline to work was not that straightforward. Also because it's research, kind of research software, so it's not really super easy to use, and it's sometimes a bit idiosyncratic and difficult to set up. So I created this kind of template project that hopefully others can fork and change And basically, in this project, you have all the configurations needed to run the full pipeline.
Matteo, sorry for interrupting. Are you showing something, because we can't?
Right now,
So I try.
I'm showing GitHub.
Okay, because we have a black screen. Maybe can you try to share again your screen?
Yeah. Let me.
Sorry.
No. Thanks for telling me, Monica. So I stopped it. Maybe it gets a bit upset when I move from the browser to Keynote. That can be.
Okay. Okay, now it works. Yes.
Okay. Thanks a lot, Monica. Yeah. So created this GitHub template project for the Cited pipeline. Comes with an example, one abstract from the Brian Moore Classical Review, which gets run through the pipeline. You can either, if you know it already, execute step by step from the command line each step of the pipeline, or, which is what I will kind of demonstrate now, you can go to the step-by-step notebook. There it's a bit more pedagogic, and actually it takes you through the different steps of the pipeline, and it explains what is going on. So what I can try to do is to clear the output and see where it works. So you don't need. I spoke enough about the pipeline. Maybe one word about this, about the Jupyter Notebook. You know that usually used to each cell executes Python code. What you can do is to use Jupyter also to execute Bash script. So if you have, you can have a print statement which is Python code, but then if you prefix your cell content with an exclamation mark, then it's going to execute a command from the shell. Sorry. So it's equivalent to opening the terminal and typing cited Loci pipeline -- version. And it's quite handy because you can show in a notebook some output coming from a shell script, which is what I'm doing, because when you install the pipeline, you get this command, cited Loci pipeline, that you can use to call each step of the pipeline, essentially. You have a configuration file, which looks like this, for the project, containing all the possible configurations of all the steps of the pipeline. We don't need to. The useful thing of this is that you can run it without knowing all the details. But then you run the pipeline step by step. So the first thing you can do is that you should do is to do the pre-processing. So basically taking your plain text and doing what is written here. So sentence splitting, tokenization, so dividing into sentences, each sentence into token, doing part of speech tagging using a tree tagger, and identifying the language of the text, because it can be in several languages. And then you get some output about what is going on. So one document to process is being found. This is the name of the file. Some other informations, the language detected, and also typically the output, where the output gets written. So this is the pre-processing, and then you can continue. So the command is quite short, because all the configuration is handily contained in the configuration file. For example, the data folder, it's specified in the project configuration, and you don't need to pass it as a parameter every time. So here, essentially, you do the NER, the extraction of the citation components on all the documents that you have in input. You can do it in this batch mode, but you can also apply it to individual documents if you like, by passing the name of the file as a parameter. Once you run this NER step, what is your output? Your output is a JSON file. I hope it doesn't crash because it's quite a big JSON document where you have all the tokens. The tokens have, for example, the surface, the part of speech tag, but then you also have other pieces of information, like notably the entities. So here in the JSON, there will be the first entities that got extracted from this text. So you have Thucydides as a mention of an ancient author. You have an abbreviated reference to Herodotus, a scope of a canonical reference. So this is the first step of the pipeline. It executed. We have some output, which is good. Now we can do this part of finding the relations between the components. So we run the relation extraction. And the relation extraction adds another bit to the JSON, saying, entity 13 and 14, for example, they are related with one another. And 3 and 4, they're also related. So it does this grouping of the entities into relations. And at this point, we can do the linking. So trying to find a match for the entities and the references in the knowledge base. And again, we run the command. We see, for example, that the citation parser is doing some normalization, so getting rid of characters that don't belong to the scope, but that they can confuse the parser. And then it's writing some output again to the JSON. And we can see now that some entities, like this reference to Herodotus, now has a CTS URN and also a work URI. This information came from the knowledge base, and it was added by the pipeline. This looks maybe all still very abstract, but if we read this data into a tabular format, we can see something that perhaps it's easier to understand. So here you have a table with...
Matteo, I think, sorry, I think the screen is frozen now.
Mm-hmm.
Try... Yeah,
I can...
we still see the relation extraction.
Okay, so let me share it again. And you should see if I select that, you should see pandas data frame.
Okay, here it is, yeah.
Okay. Yeah, so that's probably a more understandable format where you have each reference that was extracted by the pipeline being aligned. You have the idea of the document from which they were extracted. You have the corresponding CTS URN, and you also have the link to the work in the knowledge base. So it will be possible, for example, to transform this into some RDF. You also have some errors. So like in this case, it's interesting because the DK 1213, it was understood by some steps of the pipeline as being a reference. But then in the last step of the linking, there was no URN found for it. That's why it gets attributed this kind of special URN that represents a nil match. So there wasn't a match in the knowledge base. So you can see also some results of the processing here. And then if we look at the actual abstract from the BMCR, we can see that not all the references we have in there, they were extracted by the pipeline. So here we have 3 that were kind of at the beginning, but then there are some later ones. I think, for example, I spotted one the other day. I cannot find it right now, but here, I think Herodotus 578, we don't have it in there. So, and also Herodotus 704. So still a bit of room for improvement, but I hope this notebook will be useful to run all the pipeline on this example data. But if you replace in your notebook the input file, you can run it also on your data, which is the whole sense of this template project. And that was it. Sorry, slightly longer.
No problem. Thank you. Okay, so we can go back to our panel. Okay, Matteo, thank you very much for this presentation of the project, and then we can start our discussion with the questions. Please, also the people on YouTube, please, you can write your question, we can read your question and try to answer it. Yes, please, Sam.
Matteo, that was a fantastic presentation. I was really impressed with all of the work that you've been doing. I'm wondering if your work could be used to solve a problem that I've been having with the Digital Latin Library. And that is that we often get editions produced by scholars, editions of primary sources, and they include citations in them, say in an apparatus fontium or something like that. And it is a lot of labor to try to go in and link all of those citations. So I'm wondering about, using your Cited Loci project in the creation of critical editions. Have you thought about that?
Yeah, thanks, Sam. It's a very good point. It's one of the things that we would like to do, because if you think about the structures of epic poetry, reverse engineering the work of the authors in the manuscript by reverse engineering the citations is just a bit nonsensical. I mean, it's a lot of technical work, to do something that the authors, they could do at the start. So if Gabi, let's say, is writing a manuscript, he has a tool to select the URN for N81, applying a certain style, like you will do with the Zotero and the CSL style sheet. Then there will be no need for all of this. Of course, you will still need it for things that have been kind of already published, but for all the new things, you will not need it, including not only chapters and articles, but as you were rightly pointing out, also potentially editions. But there is quite a bit of work there to essentially to bring this pipeline into editors. And you need to bring it into the editors that people are using to produce these editions or these manuscripts. Typically, for publishing, you will need some Word or OpenOffice integration. And then for critical editions, I don't know what your authors are using. It will probably be a mixture of Oxygen XML and other people working in LaTeX still to produce critical editions. So you will need to integrate this pipeline into this editing environment, which is doable, but you will need to get funded for it, and it's quite a bit of work.
Yeah. It would be a really interesting thing to try, though. I think that could reduce an awful lot of effort. So that's something to explore, I think. We should talk offline.
Oh, absolutely.
And sorry to I have another question. Do you have any plans to expand the range of authors, say, beyond classical works into medieval or Neo-Latin or anything like that?
Yeah, another very good point. So for this collaboration with Rostock and the Reuter, we had to do it already a little bit, because since the publication is going up to Neo-Latin literature, we had Neo-Latin authors in there, and canonical references to Neo-Latin authors and works. That essentially they worked in the same way. So when you cite Dante's Commedia, it's a canonical reference. So it's not a classical reference, but the underlying logic is the same. So essentially we added a few of them. So I'm not an expert of Neo-Latin authors, but we have a few Neo-Latin authors in there that we had to add to the knowledge base. So potentially, yes, it can be extended to other authors, also in other literatures, provided that the references work in the same way.
Yeah.
So they are not based on kind of pagination, but they cite kind of a logical structure of the work. But this, I think, could be also for Shakespeare. I mean, I guess Shakespeare also gets canonical citations, and potentially you could represent it in the same way.
Sure.
But
there are lots of really interesting applications of what you're doing. Definitely.
Thanks.
I have a related question, sort of a sub-question to that, Matteo, which is, I've been asked specifically about your Aeneid cited Loci demo, which is very pretty and a very convincing demonstration, in addition to all the powerful work that goes on behind it. The first thing people say when they look at that, the first thing I said when I looked at it was, great, can we do this for like the Iliad? And when I presented this at a workshop that you were supposed to be at, but weren't, the first person someone in the audience asked was, great, can we do this for Dante? And so I'm not actually sure what the answer to that is. I mean, I know the answer, as you just said, is yes, one could, but is the answer is somewhere on the spectrum between, sure, all we have to do is change one parameter and you've got a website exactly like my Aeneid cited Loci, but for any other website, for any other text you like, which I suspect it's not quite that easy. Two, on the other end, it's so different that you'd essentially have to do a whole new project to retrain the algorithms, to design, to hand check the citations, and it would be another 3 years just to do that. And I suspect it's not that hard. But where in between those two do you think it is?
Yeah, I think you point to the problem very precisely. I mean, one thing is to extend the interface, and the other thing is to have the data to fuel the interface, because you need to have the quotations and the references in order to be able to display them. So the limit of the interface as it is right now is that it works for works that are organized by book and lines, but it will not work that well for tragedies, for example. They are not organized into books and lines. I think there are ways of overcoming this by customizing it for tragedies. You can have the columns being a section of the tragedy, so parodos and so on, choral sections. So there are ways of working around it. But it works as it is more for stuff that it's organized into books and lines. But the trickier part is the citation data to fuel it. So of course it would be great to have to do it for Dante, but this assumes having Dante's literature, Dante's references extracted from publications, which is another strand of work. So there are these two parts: the visualization and the data that gets into it. This said, it could be done quite easily for other works that are in Jstor. For example, for the Iliad, for the Iliad and the Odyssey could be done. So that's more a question of time and resources. But in that case, it would be quite straightforward. In the case of the Iliad, it will not be possible to have the nice quotation detection, because then for the Iliad, you will have the problem of the quality of the OCR of Jstor for the polytonic Greek, which is important to be able to do the text-to-use detection. So there is a reason why we chose the DNA, so, because it's interesting, but also because we had all the pieces to be able to put it together. And to do it for other works will take a bit more work.
Yes, so thank you for this last point, because I think this is an example of practical problems in philology we have today. So considering the different kinds of data we have, we also have to focus on data where we can produce results. So this is very important. As you said, okay, I focus on the Aeneid because there is not only an interest as a classicist, but also because we have today data that can be used to produce results, to show the model for the future. So this is extremely important. We have been learning in the last years practical problems of digital philology. Then I have two other questions. So you mentioned your work with publishers. where you can get, of course, different formats, working directly with publishers like LaTeX, or also Word files, other formats, and then PDF. With Jstor, you work with PDF, and you just mentioned problems concerning OCR, and this was my question. So given that you work with papers produced in different years, I think that that's the problem. So how much work you had to spend for extracting data from PDFs, how much, which were the results in this sense? Because with Jstor, basically you have these PDFs that we can search, of course, but for this kind of work, I imagine there are problems. And the second question is about the fact that you are focusing on papers, or at least, printed papers. So we depend on the printed format with a specific criteria for citing ancient sources, as we know, because we are humanists. But for the future, given that we are still producing printed papers, or at least we are producing digital papers, but still depending on that format. So do we want as a community to begin to think of possible new guidelines for citing ancient sources to be able in the future to extract these citations in an easier way? So do you think that this is something that we should work on, given that the format of the traditional printed paper will be around for some time, I think? So what do you think about that? Because this is an interesting thing. So you're working with that model to extract data from the traditional model. I hope my questions are clear.
No, they are absolutely. So I will start with the first one, where the answer is also shorter. So the quality, so from Jstor, I actually received text files essentially. So it's already text that gets extracted from their sources. It's the product of the OCR, and the quality. I mean, I haven't done systematic evaluation, but the quality of the Greek, it varies a lot. You have some Unicode, proper Greek Unicode in there, and you have sequences of gibberish, whatever it's found by the OCR. So naturally, the older publications, they need to have more problems with the Greek OCR, but sometimes also, you know, the text that you get out of a PDF, which is born digital, is not necessarily encoded in UTF-8, as we all well know. So in a sense, working with references, we are lucky because we don't depend on the verbatim words. So we are not doing quotation extraction. So we cannot kind of work around the problem. So for me, it wasn't a big issue. It's what becomes a bit of an issue is the OCR noise. So the sequences of characters that are kind of gibberish from the OCR, that they tend to break your code essentially, because sometimes they are even reserved sequences that are used for some other things. So your code tends to be a bit, you know, tested for robustness by the OCR noise, so to say. So that was for the OCR part. And the second question was, yeah, the problem of the pagination. If I understand it right, you mean the fact that we are citing secondary literature still by pages, right? So we are referring to classic, to printed articles and chapters, and when we cite by page. And of course, we are consulting these publications digitally in other forms, but then we are still sticking to the page to do the citations. This is, of course, a problem in a way. I mean, pagination has such a long history that works. And we are very reluctant, I think, as scholars, to move away from it.
No, my question was, sorry for interrupting. This is a possible third question about pagination, because here we are adding another layer, because of course you are citing paper with the pagination, so and you have to preserve the page. This is the reason why you look for these pages in the PDF. But in those papers where we have citations of classical sources with abbreviations, Roman numerals, etc., and your work, I know, because I have been following your work in the last years when we started many years ago at Perseus. So this is the tricky thing, so to extract those citations. So do you think that in the future we should work on new guidelines for producing citations that can be detected in an easier way by the machine. I know that finding an agreement in the community is is quite impossible. This is the reason why we have many different guidelines. But maybe, given that we are still working with this printed format and these conventions.
Yeah,
what do you think?
Sorry, I misunderstood a bit, Monica, but
no.
Now I understood it. This goes back to what we were saying before with Sam concerning the tools. So I think we cannot ask classicists to look up the CTS URLs of the literature they are citing. But what we can ask them probably...
Well, maybe this is too much, exactly. Maybe this is too much, but something...
This is a bit too much, but maybe we can ask them to select an entry from a drop-down menu, and then apply a citation style to it. So without having to reformat all your references depending on which publication venue you're submitting to, but having something like Jstor, like Zotero, where you're selecting, Harvard citation style or the Chicago citation style. You can do the same for the canonical references, saying, format them using the abbreviations from the LSJ, or format them keeping, extended titles in English or in another language. So I think this can be envisaged. We will need to integrate this if we start using meaning Word or OpenOffice or LaTeX or whatever. So you need to bring this into the editors that people are using.
Yes.
And I would be glad if we can find, some agency to fund some development for that. But
this was a bit a provocative question, but of course, this is something we have to think about for the future in general, if we want to extract data from the papers that we are still writing. So this is, I think, important. So, and the comment by Gabby. So yes, the only agreement we could ever hope would be on the CTS URLs. Well, I'm not sure about the agreement, but anyway, yes. Yeah.
Even then, we can only hope.
Yes. Okay, so thank you, Matteo, for your answer. Other questions, other comments? We still have a few minutes.
I think it's interesting, Matteo, that the accuracy ratings that you came up with, I've forgotten the exact percentages, but they seemed very similar to the accuracy ratings I was coming up with when I was trying to match what we were finding from HathiTrust, for example. Oh, did Matteo just disappear?
I think we lost him. I think he has a few problems with his connection. I hope he will be back. I'm sorry for this. Okay, he's back. Okay, Matteo, you're back. We lost you. So please, Sam.
Okay, yeah,
I was you for a moment. Sorry, it was a little shaky connection.
Okay,
towards the end.
I was just remarking on the similarity of the accuracy ratings that you were getting to the ratings that I was receiving when we were trying to match our records against PDFs that we were downloading from HathiTrust. It seems like that 70–75% rating is about as much as you can hope for in some instances, which at a certain point you wonder if it's just worth it to do it by hand at that point to make sure that it makes it all the way up to 100. But yeah, I wonder what it is about it that that just, I don't know. That's the golden question, of course. How do you get to that point where it's just recognizing without difficulty? Do you think if you added in a larger set of data say from HathiTrust or whatever to train against, that you could boost those accuracy ratings?
This is a very good point. Oops, I have some echo that I didn't have before.
I think you're coming
it's fine.
Okay. Yeah.
Yeah. So it's a very good point. There is definitely some improvements that you can do on the side, and
We lost him. Matteo, you are frozen. Yeah, we lost you. Okay. Okay, Matteo is frozen. Maybe he will be back. So in the meantime, so I don't see other questions. Okay.
Is it maybe best to conclude the session at this point?
Yeah, yes. I think he has problems with his connections. Anyway, okay. So also because it's almost over. Anyway, we thank Matteo for his presentation. You have the description in GitHub in the class outline. Okay, Matteo, you are back. I'm sorry. So we are okay. Okay, so but we have to conclude the session, unfortunately. Okay, so I want to just. Okay, so Matteo, thank you very much for your presentation. In any case, we have your class outline in GitHub, and I kindly ask you to send us also your slides. We also have the links to your project and also links to your publications. So we have a lot of documentation for your work. But now, so for next week, we will have a presentation about the Digital Latin Library. And I'm very happy that Sam Husky today was with us, and he will be again with us next week to present his work. And the class outline is already in GitHub. We have a long description with the session outline. You have readings, many readings, resources, and also an exercise. But next week we will know more about the Digital Latin Library, and again we will talk again about citations of classical authors and scholarship. But okay, so for today our session is over. So thank you to our guest today. Thank you for the discussion, and so I wish you a very good night, good morning, even that we have a big community all around the world. So thank you again, and see you next week.
Thank you, Monica.
Bye-bye. Thank you for joining us. Thank you. Bye.
Bye.